This is a Key Stage 3 presentation looking at conductors and insulators. In this lesson, we're going to look at the term conductor and insulator, and we're going to describe some ways in which heat energy can move from one place to another through a house and how we insulate and stop that heat loss from a house. You will need a pen and something to write on. To get started, all you have to do is describe the different ways that heat energy can be transferred from one location to another. If you get really stuck, go back and have a look at the last lesson and watch the video in the last lesson to help you. Pause the presentation now, come up with the best answer you can, and when you're ready, you can restart the presentation. The important thing to note in the question is the word describe. If you simply said conduction, convection, radiation, that wouldn't be enough to get all the marks in the question, because you haven't described, you have identified or named. To describe is you have to give a little sentence about what that word actually means. So in terms of conduction, you need to say that heat energy is transferred as particles collide with each other. In convection, we talk about the particles are moving from one location to another because of the thermal energy that they have gained. And radiation, energy is transferred in the form of an electromagnetic wave. Remember, there are no particles involved in radiation. Now we have two new terminologies. We've got the word conductors and we've got the word insulators. And you may have heard these words before. A conductor is the name given to any material that will easily transfer energy, specifically heat energy, from one hot part to a cold part. An insulator is a type of material that does not transfer energy easily. And again, in terms of heat, we talk about going from hot parts to cold parts. You can talk about insulators of electricity and conductors of electricity, and the same thing applies, except that it's how electricity moves from one place to another rather than heat energy. But conductors and insulators we're looking at the moment in terms of heat energy. You need to be able to name types of materials that make for good conductors and insulators. In front of you, you have some pictures of different objects or materials, and each of them is made from a certain substance. Identifying the substance will give you an example of a good conductor or two examples of a good insulator. Pause the presentation, spend 1 minute trying to work out what each of the pictures represent, and when you're ready, restart and check your answers. So pause now. Well, in terms of conductors, we have a frying pan, and that frying pan is made of metal, and metal is a very good conductor of heat. In terms of the insulators, we have air and we have plastic, and both air and plastic are very good insulating materials. If you look at the top right of the screen, you can see a picture of a house, and that's taken with an infrared camera, and you can see the bits that are hotter are the parts of the house in which heat is escaping a lot, and the bits that are colder are the bits of the house where heat is not escaping from the house very easily. So to save money, the best thing to do is insulate those parts of the house that are losing the most heat, and in that picture you can see it would be the windows and it would be the roof. Heating up a house costs money, so you want to try and stop that heat escaping into the outside environment as much as possible. The more you can do that, the more you're going to save on your heating bill. And we actually have a ranking system for insulating materials that we refer to as U values. And if you look at any insulating material, it'll have a U value. And the closer the U value is to 0, the better that particular material is at insulating. Remember, all types of insulating methods, no matter what it is aimed at either reducing conduction, convection, or radiation. And that's why it's so important you know what those methods are. Again, if you're not sure on those words, go and watch the previous lesson. So when heat tries to escape from a home, how does the heat actually escape from a home? The second question I want you to look at is, how are houses designed to stop heat escaping? It may even help to think about your own home. Pause the presentation, spend a maximum of 2 minutes, come up with answers to how does heat escape from the home, and then try and come up with how they're designed to stop heat escaping, and the pictures will offer you some clues. So pause now. So in terms of how heat escapes from a house, well, we can have conduction through the walls, the floors, the roof, and the windows, but we can also have radiation through the walls, roof, and the windows. We don't have convection because for convection to occur, we have to have the particles that are heated up inside the home getting to the outside of the home somehow, and with the doors and windows and with the walls, that really shouldn't happen. In terms of how houses are designed to stop heat escaping, well, there's lots of different examples. We've got loft insulation, which is of course the top right picture with the fiberglass, and it's got big pockets of air in there to try and trap that heat. We've got double glazing or even triple glazing, which is again layers of glass with air pockets trapped in between them. We've got cavity wall insulation, which is where foam is injected into the gaps between walls, and foam is actually a better insulator than air. It actually has a lower U value. And then of course, things like carpets and curtains will all help stop heat escaping to the outside environment. The thicker the curtains you get, the less heat is going to be able to escape out the window. When you own a home, it comes down to trying to balance out the cost of getting the method of saving energy and how much money that particular method is actually saving you in your heating bill. So for example, if you put in double glazing is extremely expensive, but it only saves a small amount of heat energy from escaping, and as a consequence, it's not always cost effective. If you look at things like draft excluders, because they cost so little money and they actually save a reasonable amount of heat energy, they actually turn out to be much better methods of saving money on your heating bills. And it's often a matter of looking at tables and comparing how much money does a particular thing cost compared to how much does it save. And we can talk about this term payback time, which is the amount of time it takes for you to save on your heating bill the same amount of money as it costs to put any particular method of saving energy in. Last thing, folks, don't forget to do the questions on EduCake. If you do the questions on EduCake, that is how I know you've done the task. I get a record of them automatically, so please make sure you have a go at those. If you have any problems logging in, make sure you email me.